This problem, we know that this economy has three sectors, E, M, and A. And information about each sector is given in these three statements. With these three statements, we can actually create a table like this. And then, for instance, the sector E, for sector E, 70%, oh, here's how I would set up this table here. So I list these three sectors here, and column-wise, that's the output of each sector. And then row-wise, that would be the inputs for each sector. Now, for instance, sector E sells 70% of its outputs to M. Therefore, I'm going to label this 70% under this column E to M, sector M. And 30% to A, so 30% to this A. Of course, that means this particular sector doesn't retain anything for itself, right? So therefore 0% for itself. Similarly, sector M, 30% to E, so 0.3 to E, and then 50% to A, so 0.5 to A. Therefore, it 20% left for itself, so 0.2 here. We have to do a little algebra here to get this 0.2. Similarly, you can set up the numbers for the last column. Once you have those, then you can set up equations from each row. For the energy sector, this is the total for this energy, right? So therefore, PE is going to equal to 0.3 PM, the price from this manufacturing sector, plus 0.15 PA. And for the second row, you have PM equals 0.7 PE plus 0.2 PM plus 0.3 PA. And the last row, PA equals 0.3 PE plus 0.5 PM plus 0.55 PA. If you continue to read this, you certainly have a set of system of linear equations of 3, right? And then we can quickly solve those using the matrix. But now let's take a look at the requirements. We want to make PA as free variable. Therefore, when I write my equations, I'm going to keep that in mind. So here I'm going to write that as the first equation is going to be PE minus 0.3 PM minus 0.15 PA equals 0. And the second one is, if you simplify, there's a PM, there's a negative 0.2 PM. So you have 0.8 P. Oops, I probably want to probably want to, so 0.8 PM, right? And I have how many PE? Negative 0.7 PE. And then negative 0.3 PA equals 0. The third one is negative 0.3 PE minus 0.5 PM. It's 1 minus 0.55, that means plus 0.45 PM equals 0. And then you can set up a matrix, which is the first row, 1, negative 0.3, negative 0.15. You really don't need to include a last column. Last column is going to be 0 all the time, but you should keep that in mind. So I'm going to just keep these three columns. The next one is negative 0.7, 0.8, negative 0.3, negative 0.3, negative 0.5, 0.45. And keep in mind, this is the first column is for the first column is for the PE, second is for the M, the last one is for the A. Now once you RREF it in your calculator, the first row is this: 1, 0, negative 0.36, 0, 1, negative 0.69, and the last row is 0, 0, 0. So therefore you can, again one more time, this is PE, PM, PA, and you still have the last column 0, 0, that's the constant column, which is this column, right? So you need to move this to the other side when you write it out. So you have PE equals 0.36 PA, and then PM equals 0.69 PA, and PA is free in this case, which is 1 times PA, right? And if you factor out the PA, and therefore this is your answer, right? So factor out the PA, so it's going to be this vector times the PA. That's the answer.